Okay. Hello, everyone. Welcome to the week 6 of this iteration of problem-solving sessions for your course. Uh, my name is Raj, and I'm a PhD student at IISc. So today we'll do the week 5 programming assignment, and then some questions, ideas on week 6 syllabus that was there. Um, Okay, so again, let's try to make it as interactive as possible. If there is any technique that you have used, in solving this assignment, you can let me know, so that it'll be easier for other people also to, improve their solutions. And if you have any doubts regarding the current, what code has been shared by the program instructor, we can discuss about that also. Okay. Um, Fine. So with this, we'll start. The So in this particular assignment, the idea is that you should be able to read data from standard input and then try to do some sort of an operation on the data that has been given to you, right? So in this, firstly, we have some information about, let's say, specific courses which come up in this particular format on the standard input, which is your course code, then the course name, then the semester, year, and instructor, and then about the students, some information, roll number and full name, and then about some grades, right? So basically, for the particular course code, when was it, which semester was that course taught, and then the year, and then that particular roll number got which grade, right? And grade is a letter grade. So basically, here we have different types of grades possible here, and each of them correspond to some grade point. Okay. So the grade point of grade point average of a student is the sum of his or her grades divided by the number of courses. Now, what they want is the output to be basically um, line giving the grade point average for each student in the following format. So for every roll number, their full name and the grade point average, right? So here, what we have in this third line number is basically we have each course code, how much grade they got. Uh, what we want is basically the average across these all grades. Okay. Um, so this is the particular, one sample input that they have. So for example, let's say if you see SLY2301, right? So this person has two, courses that they have taken. So basically there is one, they've got an AB, one they've got A, right? And AB corresponds to 9 and A corresponds to 10, right? So hence their average is going to be 9.5. Right? And what they want is also for you to be able to round it off to two decimals, two which is after the decimal point using the round function. Okay, so we'll go through the the code that was provided here, and let's see if you have any doubts on that. Okay, so first of all, we code up the grade to number because again, remember, we want to average the grade point, right? So we need to be, but what we have the data in terms of the these strings, that is A or AB and so on, right? So hence we basically have to convert the grade letter, the string to a number, right? So we're doing that using this particular function. So where we have for each switch case sort of a thing, for each case we have some number that they want to return, right? So any thoughts on how we can achieve the same functionality, but without using this in like this a separate function as such? So basically, we want to map a string to a number. Any thoughts on how we can do that without using a such a long function that is being written here? Any thoughts on that? So which sort of data structure would be useful when you want to map things from one thing to the other?
Dictionary also.
Right, exactly, right. So we can have a dictionary setup here. So how would you replace this function if you have to use dictionary here? For example, let's say if I have to uh, perform the same operation that is basically given a grade, I want the number. How would we do that?
Grade to number equal to dictionary. Mean that one. Pair of ordered pairs.
Okay. So here basically it would be something like this. Is that correct?
Yes.
Right? So for example, then you'll have A, B, B, C, C, then C, D, and then D, right? So it's going to be 10, 9, 8, 7, 6, 5, and 4, right? So this is what we have A2 number dictionary. Um, but there is something that's happening here which is not covered as a case here. Can anyone see? I'm sorry. Uh,
Else return 0.
let's return.
Not covered.
How to solve for that? So this is more of a like a helper case. Basically, let's say in case you find some inconsistent data that you have, you need to be able to handle it in some way. So here the approach taken is return 0. So how can we do that for a dictionary? So in dictionary, basically, let's say if I have a um, right now there's a function that there's a function called dot get, right? So d dot get of a, right? So this performs similar to writing d of a, right? So okay, so let's say the value. Okay, so this is exactly what the the dot get function basically does this key operation, right? But where they differ is basically in handling whether a key is not present, right? Sorry, if a key is not present, right? So let's say if I give uh, C here, D dot get of C versus D of C. Can anyone tell me what will happen for the line number 10 here? If I do, if the dictionary is defined in this way, if I do D of capital C, what will happen? Will there be an error? Will it give me 0? Will it give me what? Any thoughts?
Not defined.
It won't be not defined. It'll give you a key error, right?
Yeah.
So we had discussed exceptions some time back, right? Yeah.
Yes.
Uh,
Clear.
Key error, right? So
Yes.
that's exactly what we have here. Okay. So, but whereas when you do d dot get of c, that basically handles a missing key in a more gracious manner, right? That is basically what it will do is it will say that there was no value, there was nothing present against key C, so I'm going to give you none. Okay. Now, let's say you want to tell you don't want none, but what you want is let's say some default value, right? So if a key is not present, I want some default value. The default value you can put it here, right? Some default value here, right? So let's say I will define the default value here as 0. Then what will happen is the same code previously it was going to give you d dot get of c will give you none. This will give you the default value.
So data point B is private. Okay.
Okay. Yes, correct, Vivek. So we'll get a get of c comma 0, right? So again remember, so d of let's say some unknown, this one will give you a key error. Okay. Uh, d dot just sorry, yeah, d dot get, if you just do this will give you a uh, this will give you none as the output. And if you were to do something like um, d dot get of some number, something, some default value, let's say, okay, that's going to give you the default value as the output. Okay, so with this in mind, can anyone tell me what, how would we use this dictionary that we have made? So what we will have to do here? So here, to handle the else case, we can just say return this grade to number dictionary of grade, right? But not of grade, dot get of grade, comma 0, right? So if the grade is matches exactly the dictionary key here, you will get the respective value. If it doesn't, that's exactly the else case. Okay. So this is the one way to do the same sort of an operation. Okay, fine. So now with that in mind, so the way we get the data is basically in a very string sort of a format, right? So we get, for example, some items with some this special character like a tilde symbol between those different items in the string, right? So we want to be able to store them, effectively. So for that, we use this different dictionaries here. So the first is the roll number, then you have a grade point and course count, right? Now, the idea is always the information will have the first line to be courses, then students, and then the grades, and then we have the end of input, right? Which tells you that all the data has been provided. So here, so this particular line of code tells you that until you find the courses ka, the the word courses, just keep on taking the input as random, right? So we don't want to, we won't use this information in any way. Then same thing regarding the students also, because what we want, see, students information is telling you. Yeah. So the course data information is not required actually, right? Because we just want to know the average of all the courses. That's it. We have no need to know the course name with which the particular course code was present. So hence we are not caring about anything regarding the courses, and we move to the students data, right? Now, so once we reach the students string, we now read the information carefully, right? So we first get the first line of the students information and keep on reading the information until we get the grades ka string. Okay, so remember this part of the code of the text, basically the students information is being read from here. Okay, so from this particular line number 50 to line number 58 is when we are reading the student information. And this while loop tells you that once I have found the grades, I will leave this particular while loop and go to this particular line. Okay, fine. So then we already know that in the student's information, we have two things which are going to come. That's basically the roll number first and then the name, right? So hence, what we do basically here is that we will split the line, whatever string we have based upon this character like tilde, right? So the first value will be the roll number, second number will be the name, right? So then we have the roll number of roll as name because we want to basically keep the name somewhere, right? So with the roll number, so hence we do that. Then we're saying that the grade point make it to 0 because we're going to add it up and over whatever uh, courses they have taken. And then we also have a course count because we want to take an average, right? So different people can take different courses also, right? So hence we have this grade point and course count different points here. Okay. Um, then we have the grades data. So until we find the string like end of input, keep on reading the grades information. So for that, again, remember, we have the it's coming up in this particular format. So where I have uh, uh, yeah, so we have like course code, then the semester, year, roll number, and grade. So again, remember, we don't need to know the course code as such, or the semester or the year. We just want the roll number and the grade. So the roll number is going to be the 0, 1, 2, and then third, right? So the fourth element, which is the index 3, will be the roll number, and the grade will be the fifth element, which is the index 4. Okay, so we use that. We then add up the grade, grade corresponding to that particular string, and we also add the number of courses that they have taken. All right. So with that in mind, we now have the final output, which is basically we just need to print the roll number and the grade point average. Okay, so for that we use this particular sort of system where we can just provide use the roll number dot keys to get each and every roll number and sort them based upon using the sorted helper function. Okay, so if we have the course count more than 0, we then just do the division. That's the average part of it. And in case it is equal to 0 or less than 0, the idea is that because so this will get division by 0 error. So just to be sure, we just don't do the particular averaging here, right? And we give the GPA to be 0. Okay, so this is what the code is. Let's just see it in action. We'll take the sample input. Okay, and yeah, so run. So again, remember, we'll pass in the whole standard input, everything together, and then what's running? Okay. Let's do debug. Yeah. Um, yeah. So so remember input dot strip is going to give you the first line, and we're going to continue until we find the student's string. Okay. Um, just a moment. My camera is not on. Okay. Yeah. So we'll keep on going until we find the student's information. So we can look at the next line basically coming up here, right? Yeah. So now we see the next line is basically the first student, which is basically your SLY 2301. Now, once we have the student, we are just going to pass that information using the split function. Okay. So we have the next line to be this particular information. If I were to split this based upon, um, you know, tilde symbol. So I will get first the roll number and then the name. Okay. And by the way, in case you know the exact, the number of elements that you will get after splitting, you can do this also. Instead of doing this particular thing, you just write roll comma name equal to next line dot split, right? So again, remember we have seen this sort of uh, this sort of a thing in tuples, but it works in list also in case you know the number of items you would get. Okay, so let's just see that I'm going to say A and B if I were to do it. Okay, so A is the roll number and B becomes the name. Okay, so both are fine. Uh, and uh, and we have the roll number dictionary having the particular roll number against the name. Okay, so we do that, and let's go to the next part. So here we have now all the individual roll numbers and their particular names. We now have we reached the a part called grades. So hence we are in the grades section. Okay, uh, so we do this same thing here. Uh, these are all done. So we are here, and we then see the next line is the first line that is basically of the grades function, grades part of the code, right? And when we split it with tilde, you, you get the 5 parts, right? And the third and the fourth part are your roll number and grade for the particular student. Again, same thing here, because we want the third and the fourth element and not the initial elements. So what you can do is something like this. Roll and then grade equals to next line dot split. Okay. So here, basically, what will Python do? So we are saying that we have 5 elements. So keep those 5 elements to these 5 values here, right? So roll number will get the fourth value, which is the roll number, and a roll variable, and grade will get the grade of the student. Okay. So let's just see that here. Let's say A, and if I give here, right? So A is basically the roll number and B is the grade. Okay. So you can do it in this form also. Again, this is possible only if you know the exact number of elements you would get after splitting, right? Otherwise, this is a better way to go about this. Okay. Uh, yeah. So yeah, so you can see here the grade point dictionary will keep on updating based upon which student we have gotten till now. Okay, and also the course count dictionary. Where is the course count dictionary? Yeah, here we go. Right. So that's the idea. And finally, once everything is over, we'll now come to the. So we now have all the information about the particular students and their course counts, right? Uh, and then we basically want to want the output in this particular form. Okay, so so just sort the roll numbers based upon the patient roll numbers, and then just take the sum of the grade points with the course count average, right? So we'll get one by one each of the students averages here. Okay, is this okay? So we'll get exactly what we have been asked here. Okay, so we can see here this Bertram Aubrey person uh, has not taken any particular course, right? So hence we have we print zero against that particular person. Okay. Any doubts regarding this implementation? No doubts? Everything is clear? Okay. So yeah. So in your week 6, you guys also went, I mean, there's a idea of something called as stacks and sets and queues. So um, let's say, okay, so does anyone know what a stack is? What do you know? Uh, how do you define a stack basically? Anyone?
Last in, first out.
Right. So stack is basically a LIFO sort of a system, right? So this basically means last in, first out, right? So remember, this is basically the way in case you when you use a lift, right? So the person who has gotten in the first will go towards the end, right? And that person will be the last one to get out, right? Versus somebody who has gotten in first will get out, the last, right? Uh, okay, so this is basically the way your lift sort of thing works, right? In general scenario, and this is basically called as a stack, right? For queue, what is the appropriate this one? Anyone?
FIFO, first in, first out.
P4, right? So that's basically first in, first out, right? And this basically in case when you're in a queue, right, to take, let's say, some sort of a grocery or in bank or something like that. All right. Okay. So with this in mind, let's say so one use of stack comes in a very general scenario. But before that, let's say when you're writing your Python code, right? You use brackets to make sure um, your expression basically does the evaluation properly, right? But before you run the particular code, your Python interpreter has to understand whether the code is correct or not, right? To be able to actually run the code. So for that, imagine, let's say if you had written a code something like this, right? Um, 2 plus 3 minus 6 and then finish, right? So the number of brackets are not matching, right? The number of brackets which are opening and closing are not matching. So hence Python is going to raise you a syntax error. I think syntax error only, right? So, so how would you, let's say, design a compiler or a interpreter which can compare basically, which can understand whether the brackets are rightly matched? How would you, let's say, go about doing this? Any thoughts on that? So this is the algorithms course also. So let's think about uh, how would you solve this problem, right? So where, let's say, you are given an expression which has brackets and some numbers and some operands and all of that, but and you want to know whether the brackets are matched correctly or not, right? How would you go about doing that?
Post-stack operations or pre-stack operations.
Uh, yeah, so post-stack operations, that is one possibility, but do you need that complexity here for this particular problem statement? Let's say I say that, okay, only one type of brackets are there. Right? Let's say only round brackets. Would you still need to use stack though? Any thoughts on whether um, can we make it a bit simpler?
The number of left parentheses should match with the number of right parentheses, right?
That's it, right? So the number of left parentheses should match the number of right parentheses, right? So if you have a, let's say, a single type bracket, you can just basically do something like this. Let's say for uh, C in, let's say, some string that you get, just check if C is equal to some character like this. That's the open character, open bracket, right? 2 plus 3 minus 6, right? Something like this, right? And what I will do is I will basically keep a count, let's say, right? Count is 0. And I will increment the count whenever I see a left parenthesis, right? And if I see a right parenthesis, right, then I will just decrement the count, right? So this will tell me at any moment of time when I'm having the code going on, right? It will tell me how many number of mismatched parentheses are there, right? Now, once the code is over, once the complete string is scanned, what I need to check is whether count is 0 or not, right? So you can just say matched, else you will say print not matched or something else. Okay. Does this make sense? Okay. So for example, if I run this code now, it's going to tell me it's not matched. And if you and you can do some additional stuff also. You can say by how much it's not matched and so on and so forth. That's other stuff that you can do, right? Right. So by one, so we were seeing that there's one extra left parenthesis, right? For example, if I have multiple right parentheses here, it's going to by match, not match a minus one. That's it. I have multiple, I have more right parentheses. Okay. Um, Now, when you want to do for multiple type of brackets, right? Um, any can I use a similar sort of a strategy? If not, why not? Any thoughts? Anyone? So when you have multiple type of brackets, the issue basically comes up. Let's say if you have something like this, 2 plus 3 minus 6 plus 8 into 3, or let's say bracket like this, into 3 plus 6 And then let's do this, something like this, right? And like this. Okay. So here the idea, the issue basically comes up is that within a particular sort of a bracket, let's say, for example, I have this square bracket here. Within that particular set of a bracket, the bracket uh, should match, which is your round brackets in this case, right? So if I have, for example, something like this, so I cannot just do a simple, you know, uh, count each unique sort of a thing for this reason, right? So here I have the matching a close bracket, right? Matching close bracket for this open bracket here, open round bracket here, which is not right, correct? So what will end up happening is you will have to sort of solve this problem in a for each sort of a bracket pair internally, which can be quite uh, complex in that sense, right? So one sort of a way to solve it is using stacks, right? Now the person who told about prefix in this one, yeah, separately match each type, right? So how would we want to do that? So any thoughts on how would we do that? How can we use stack to basically be able to validate this sort of a string? Any thoughts? Okay. So so for stacks, basically, we will represent the stack as a sort of like a bar, a bucket which is growing from bottom, right? So as you put in water, it keeps on rising its level, right? So in this case, what we are going to do is basically consider so as an so when we find, for example, let's say an open bracket, we're going to add uh, so an open bracket, we add it to the stack, right? Okay. And when we find the close bracket, what we're going to do is we're going to do a simple check, right? So if it's the same type of closing compared to the opening, right? Uh, so sorry, if the top of the stack, basically top of the stack. Remember, what is the top of the stack is basically the recent most bracket. Recent most open bracket that you found would be here, correct? Now what we will do is we'll check the top of the stack. So in case the top of the stack matches the closing, uh, matches the opening, sorry, matches the closing one, right? Then what we'll do is we'll pop it off, right? We'll remove it off. So that basically indicates that I have found a particular respective closing and opening. So therefore, this pair that I found is a complete pair in itself. Okay. If it doesn't match, okay, if it doesn't match, then that basically indicates that it's not well formed. Right? It is not well formed, right? So for example, in this case, when we have, we will, uh, yeah, so we will basically, first we'll push this on the stack, right? Then we'll push this particular thing on the stack. Now, once we find the closing bracket for the round bracket, we will take it off from the stack. So this is not there anymore, right? Then we'll see an opening bracket. We again put it on the stack. Again, we have an opening bracket on the stack, and then we see a closing bracket, right? The recentmost element on the stack is basically a closing opening round bracket, right? It is not the it's not the close opening square bracket, right? But what we want is whether it's a opening square bracket. So hence this particular string will fail here. Okay. So by saying that basically what we have is not the right form, well. Hello everyone. I'll just join back in a minute. Okay. Hello. Can you guys hear me and see me and see the screen? Hello. Okay. Fine. Um, just a minute. Yeah. I have to shift my locations. Yeah. Okay. So where were we? We were looking at basically the whether what would happen if in case this sort of a particular check fails, right? Um, so any doubts in this sort of idea? So hence, so uh, here allows us to match a one-to-one whether a particular bracket has corresponding closing bracket. Right? This is the use of stack. So in multiple brackets here we will have we using stacks will make it easier. Any doubts in the concept? Okay. Um, so, so your quiz basically consists of two questions on mini. Okay. Um, how many of you know what a heap is? Can you even tell me what a heap is? Can you guys hear me? Uh, and can someone respond if they are able to hear me or not? Um, okay. So, heap is an idea which allows you to, extract, let's say, max values or min values efficiently compared to the usual sort of simple array that you have that you would have, right? Uh, and it's a so basically it's a data structure um, which allows some efficient operations and which we'll see which basically is regarding the accessing of max or min elements, right? So can anyone tell me what a max heap? I mean heap in general in your lectures we have there was idea of heap, right? Um, anyone want to pitch in? You can pitch in. Otherwise, I'll continue. I'm frozen. Is it? Okay, let me just reshare it. Yeah. Can you see the OneNote here now? Does this work? Sorry. Uh, okay, fine. Yeah. Oh, just right. Uh, the idea is that let's say when you have a in this data structure, we basically maintain this basically is something of this sort where you have let's say some root element and then it has a set of children in it, right? So just a moment, guys. Fine. Um, So what we so we have so a tree basically will have, let's say, one particular sort of a root node, and then each node in that particular system would have some children nodes in them, right? In heap, basically, the way we store data is in a sense that, let's say, whatever value you have in the root node, let's say 23, for example, here, it will have two children, right? And those two children should have values which are less than or equal to the root node, right? And this sort of a structure is followed in every sub part of the tree. That is, let's say, in this particular main this one, you have this three elements. Let's say now if I have some values present here. If you consider this as a sub tree, or let's say a three elements a sub part of this particular graph, this also will follow this particular structure where this root node, let's say x, will be greater than or equal to the elements children here. Okay, this is the idea of a heap. This type of heap is called a max heap, right? So max heap, because what we're doing is we're saying that the root should be greater than or equal to the children. Okay, in min heap, the idea is opposite, right? So in min heap, you have the root which is less than or equal to the children. Okay, so it's a very small difference, not much changes between these two in that sort of an idea. Okay, and again, remember, um, uh, the way we represent heaps using arrays makes it a very efficient sort of a way to, a very easy to store sort of an idea. So where the idea is that you will basically keep these elements in respective order, right? So the root comes at the 0th location, that is, let's say, the first location. Then you have one, then the children, the left child first, then the right child, and then the left child of the left child. That is this one, right? So then you have 3, 4, 5, and so on, right? So you would store it in a list in this in an array in this particular format, right? So let's say if I have, let's say, a list which is something like this: 23, 10, 14, 2, 3, 3, and 6, right? So let's say if I have this basically corresponds to the heap where I have 23 in the root. The left child is 10, okay, second element. Then I have 14 is the right child. Then, so these two are done for the first root element. Then whatever we have, you will fill it as the children of the left child of the root. That is, then you'll have 2 here, then 3 here, and then 6 here. Okay, so this is the way you will basically design and understand heap and store it as an array or a list basically in Python. Okay, so let's say if you had to check or if you have to check if a particular heap is valid or not, right? And when I say valid, basically you want to know whether this sort of a rule is followed in every single subtree, right? Every single sub part of this particular tree, right? So how would you go about doing it? Anyone wants to start trying out here? Right? So given a list, let's say I have a test heap here, which is 20, 10, 12, 3, 4, and 6. We want to check whether it's a valid heap or not. It's valid heap of test heap. Okay. How would we go about doing it? You can mention in chat in case if you have an issue with the mic or something.
Yeah, root should be highest. Check for the root whether it is highest or not.
Right, but so then so that will require basically checking whether that particular element is greater than everything, right? So let's say, for example, Okay. So root will be what basically? How do I access root?
First element. First
First
element is,
element, right? So here
yeah,
root is heap of 0, right? So you're saying check if root is max of
yeah,
all
minimum. Math,
elements,
yeah.
correct? So
Yeah.
again, so we'll deal with max heap here, okay, for now. Yeah, so check if root is max of all elements, right? So how will we do that? Let's say if I do for element in heap of 1 : correct? So because obviously root is the first element, we just need to check in the remaining elements whether it is a max or not, right? So if root is greater than or less than the less than element, then say it is invalid, right? Okay, but is this enough?
You have to check for all other elements next. Left, right.
How will we do that? Any thoughts? How would we go about doing it? So see again, remember in here talking about whether that the root is greater than child or not is true for that particular subtree, right? So left child, right child. That is all you need to check, right? Because the idea is the- that's the main idea here, right? So just because there's a structure, there's a local structure in this tree at every location, you can utilize that local structure to make your operations more efficient. Now here, if you see, this list as such is not sorted, right? 14 is, more than 10 and 10 is less than 23. So there is no order in the list as such, but locally there is an order. So 23 is greater than 10 and 14, and then respectively, right? So we just need to check whether that local ordering is true or not. Okay. So how would we go about doing that? So let's say first I need to know what is the number of elements in the heap, right? So I will take, let's say, n is equal to length of heap. So now for, I just check in for each element, right? For each element, how do I access the left child? What is the index of the left child of a particular element? Any thoughts? If I give you the index of a particular node in this array, which represents the heap, right? What will be the element of the left child of that particular element?
-1. -1 of that. Index -1, left child.
Fine.
Index +1, right side, right child.
Index -1 is left child. For 0, then what will be? It will be -1.
Oh. Okay, index +1 is a left child. Index +2
Then for
is
1, 2 will be the left child.
yes. 1 will be left child, right? 2 will be right child, right? +1 +2.
So again, basically remember what is happening is at every level you are actually sort of doubling the number of elements already present, right? So that you will capture in this idea of left index is 2 into I. Okay, so 2 into I is the number of elements that are present, including in that particular that level. Okay, then +1 will tell you the left child index. Okay, and right index will then be simply 2 into I plus 2, right? Or basically you can just write left index +1. So remember, whenever I have the right child is always +1 of the left child. Okay, that much I hope is clear. Left child will basically be, let's say if it is 0, then 2 into 0 plus 1 is 1. 1 into 2 plus 1 is 3, right? So that's how you will get, for example, we have 2 here. So 2 into 2, 4 plus 1 becomes the 5. Okay, so you would get your left index and right index in this form, right? Uh, okay, so now that we have the left and right index, what is the check that you want to do? What's the property that we have to check? So what should be more than what? So we're talking about the element at I, right? So if heap of I, basically, if it is greater than or equal to the left hand, right? So this basically we're comparing the parent with the left child. Okay, we're comparing this particular scenario. So if this is, if it's so what we want is it should be greater, right? So if I can revert the condition, if I say less than, then this pakka not a valid heap. Is okay. So basically we're saying for any node. So we are going through all the nodes in the heap, right? So for I in range of n, so we'll say that for any node, if any time I see that the left child has higher value than the parent node, then it's not a valid heap at all. Okay, and the same condition has to be true for the right child also, right? So heap of right index, right? This also return false. This is okay. Any doubts here? Any condition that we are missing? So it's possible that there is no element only in the left index. Correct? Right. So that right. So then so I would say if left index is less than n, and right, condition tells you basically. Okay. So this is basically checking with the left child exists, and then you compare the parent with left child. So you're basically sort of checking whether the left child exists or not. So because n is the number of elements in the heap, if the left index is less than n, then that means that there is a left child. Then that particular child there's some value in that particular index, and then you compare that with respect to the parent. Okay, same thing here. The right index is less than n. That's it, right? Okay. So any doubts here? So somebody's asking, is this like binary algorithm? Uh, you mean binary search algorithm? So it is it, it feels very similar to that because of the fact that this is like a we are working with a binary tree, right? So we always look at, let's say, one half compared to the other and so on. Uh, so it will feel like that, but again, remember there are these are two separate problems. In binary search, the idea is that you want to find an element in a sorted array already. Here you're constructing a specialized data structure to be able to do some sort of a operation going forward, which is your which will be heap sort. That's the final end goal. Yeah, you're right. Somebody said check index overflow. That's what you want to do here. Correct. Yeah. Okay. So we check that using this particular sort of an option, right? Left index less than n, right index less than n. Okay. So this tells you whether it's a valid heap or not. So let's just try it out. Um, oh, none. Oh, I didn't return. So let's say if everything is okay, then we'll just return true. Okay, so we say yes, it's a valid heap. Again, remember, this is a valid heap because um, yeah, see the elements here. So this is going to be, so have the heap is like this, right? So it's 20, 10, 12, 3, 4, and 6, right? So 20, 10, 10, and 12. I hope you can see the screen. Then, so once you have 10 and 12, then you have 3 and 4, and then 6. Okay, so as you can see, at every subtree, we see that the root is more than the either of the children. And so it's a valid subtree, a valid heap, right? Let's say if I were to exchange 4 and 10. Okay, if I were to give uh, 4 here and then 10 here, right? So this will basically become 4 and 10, which is not a valid heap. So let's just see if the code works, and it says false. Okay. Any doubts in this particular part of the code? So we're just checking whether a list of elements given to you is a valid heap or not. It's fine. All right. So now let's try to do the insertion. Okay. So let's say, yeah, let's say we'll work with the valid heap here. So let's say I have this heap and I now want to insert, let's say 21. Okay. So I want to insert 21. So the approach of insertion in a heap will basically be whatever is the last available location. That is, so here again, remember, because in heap we want to fill the binary tree in a sequential manner, right? So in this case, I will have basically I will first insert 21 here, right? 21 beside 6 as a right child of 12. Yeah. But now, what ends up happening is that it tries to, I mean, the condition of heap is not satisfied. That's basically because your 12 is less than 21, right? So then what we'll do, a very simple procedure is or exchange 12 and 21. Okay, so this will end up giving us a heap, an intermediate heap at least, which is of this form: 21, 3 and 4, 6 and 12, right? So here now, this 21 is fine, right? But again, there's a problem with respect to this 20, right? Because the root is lesser than the child. So we then have to, exchange these two further. And this will give me the final heap, which is 21 and 20. So some time to show. Yeah. Okay. So now it's a valid heap because we see that your 21 is more than 10 and 20. 20 is more than 6 and 12, and 12 is anyway leaf node. There's no problem with that. Okay, fine. So that is the idea. Uh, so we'll do it step by step, right? So let's say so as I said, the first element, the first thing that we have to do is basically just insert the element in the recent most location, correct? So how would we do that here in this case? Any thoughts? So heap is a list, correct? So let's say we'll try to do this. Insert 21. Okay. So how would we so the first step, what is the first step that we have to do? Any thoughts? So the first step is basically just adding the element at the end, correct? So how do we do that? We just say heap dot append of element, correct? So once the element is already is basically just see whether we are in the correct location, in the correct rule or not. Okay, so um, how would we do that? So first of all, the elements location that is there, there is the most location that we have. That would basically just be the length of heap minus one, right? So let's say I'll call this I. Okay, so I, so or we can do something like yeah. So so we can do one thing basically. Once we have given put the element in its location, we just need to check the parent, right? That will become easier because when we start doing stuff in that way, right? So what with the parent of I? How do I get the parent index, by the way? If I have the index of a child, how do I get the parent index? So if a parent index is P, let's say, we know what the left child index is going to be. That is 2P plus 1. And the right child index is 2P plus 2. Correct? So if I want to get the parent index from L or R, how would I get that? Anyone? So one very simple thing to do is just checking whether it's a odd number, even number, right? So if it's even number, the right child. So if it's a right child, then I can just do, correct? Just invert this sort of a this thing to get P, I minus 2 divided by 2, right? This will be the parent, correct? Else, if it's an odd number, the parent is just going to be I minus 1 divided by 2. Is this okay? Is this okay? So what we'll do is let's write some helper function. So basically, correct parent. So what this will do is it'll take and will basically just correct the particular thing. That's basically exchange the parent and the E. Okay. So anything child index. Child at some uh, parent is this, right? And how do and we fix it how? We fix by saying whether we just exchange And we can do that by saying heap of parent, comma heap of child. We just need to swap them, right? So we'll just do heap of child, comma heap of parent. Okay. Is clear? At least 2020 line. There is discrepancy between the child and the parent. That is, the child is bigger than the parent, larger than the parent. We need to correct it. And the approach to correct it is basically just swapping the particular child and the parent, right? The swap operation is happening here. Okay. And the parent index you will get by using this particular function. Okay. So we'll just make it a bit more clear. Child index. What is this parent index? I divided by 3. Why will that work? Just see, no, for 3, what will get the output as what? 3, 4. For 5, you will get the output as what? 5 divided by 3 will be 1 point something. Correct? Which is not true. 5 ka parent is 2. Okay. Fine. So now we have a function which can correct the parent, correct the subtree. Okay. In case I have something. So now we'll start with the I, that is the recent most index that was added. And we have to do that until some condition is true. So let's just we'll see what the condition is in a bit, right? I need to check whether the heap of so heap of I is basically that particular so we can just do this step index child index, right? And we can do this here. So basically the parent index here now. Parent index is basically yeah. So here the child index is basically I, right? The recent most element was at I, added at I. So I want the parent index for that particular element. And I just check whether the heap of I is, what do I check? I have to make the correction when heap of I, there is a child, is greater than the parent. Okay, make the correction. So correction again is simple one. So just do that here. And just do. Is this okay? Remember, so we're starting from the recent most element which was added, which is at this particular index, correct? 0 to n minus 1, right? That's the index. So this is a recent most element that was added at this location, and we get the parent location here. In case the child index, the child is greater than the parent, we need to swap, correct? And if that happens, we then need to still check whether the new parent that was made is that greater, is that proper compared to its parent or not. Right? That's exactly what we did now. Yeah, this is exactly what we did here. Right? So we first added 21, then we even with 12 in case. Now one, right? Two child index as the parent. Is this idea clear? Why this is the case? So the new child becomes, yes, that's the idea. So the new child, there is a new in the sense, basically in the next cycle of the loop, this becomes the child, right? So that the previous parent is in this loop, whatever the parent was there, that becomes a new child. All right. Now once that is done, now when will we stop? We will stop whenever the child index has become, right. So because a root has no more points, right? What is the index of the root? That is 0, right? So while child index is greater than 0 is when you will keep on doing this process. Once it is become 0, you will stop this process. Okay. Any doubts? Any thoughts? So let's see if this works. Right. So now let's see what's the new heap that it has gotten. Is it correct or not? Right. So yeah. So see here, 21 is the first element, then 10 and 20, that's correct. Then 3 and 4, and then 6 and 12. Correct. So after insertion, the and doing all these operations, we are correctly in the heap condition. So so whatever we have gotten at the end of this insert operation is still a valid heap. Any doubts? Any thoughts? Okay. Now let's look at the deletion operation, delete max operation. So because we have this uh, it's a max heap, right? So we'll look at delete max. If it's a min heap, you will try to do the delete min, because basically the idea is that you want to remove the root element. Okay. So let's say we have this new heap, right, which is this 21, 10, 20, and all of that. Let's make a copy of that. Yeah. So now you have this heap and you want to delete max, right? Again, as we know, as I've already spoken about it, that if your I mean, in the max, how so in max heap, you basically end up removing the root, right? And the idea here is that what you will do is you will so you cannot just keep it empty, because remember again we're storing it as an array, right? So if you remove the first element, the second element becomes the first element, right? So how do you do that, right? So you remove this out and you first make the last element to insert here, right? Okay. So now this will become this particular swapping will make it in this form. You will say 12 and 20. So 3, 4, 6. That's it. Right? 12 has gone here. So your heap has become one less element now. Right? But again, as you can see, the heap rule is being violated in this particular part of the subtree. Right? So again, the idea is that we want to fix the uh, subtree one by one, right? So here what we will do, we will say, okay, you exchange this particular element now, right, with the maximum of its children, right? So here 10 and 20. So I will take 20 and exchange it here, right? And this will give me a the next iteration will be something like this. It will be here 10, 12, 10, So 20, 10, 12, and then 3 and 4 are unchanged, and 6 is here. Now 12 is here, and there is no need to further go down because it's already in the proper heap condition. Okay, is that clear? So that's the particular operation. Now, can you help me write the code for this? How would we do the delete max of heap? And remember, what we want is we want the max element back from the heap, right? Any thoughts? Anyone? The the first line of the code. What would be the first line of the code? Again, as you can see, the steps we followed here, right? Anyone? So again, we are going to remove this element, and this element might get lost. So what we'll do first is we'll just keep the max element. There, we'll say max element to 0. Okay, is that fine? And then we'll swap the whatever the last element was there with the first with the root, right? That's exactly what we're doing here. After deleting it, we move the last element to the root location, right? So that is done basically. For that, I will need then how many elements are there in the heap, right? To know the last index, and then swap them. Heap of 0. So not swap them. Heap of 0 is basically heap of n minus 1. Is that okay? Correct. Last element becomes the first element. It's as simple as that. So basically, the last leaf node becomes a root, right? And again, remember, we have to change the heap because the heap, the last element is now no more present. We'll just do the making sure we just consider only the new heap. The element has been removed. Right? And now just update the yeah. I think you're back. Can you guys hear me? Some issue with the connection. Yeah. So we'll just update the length of heap again. So it's basically, I mean, there's no, you can either do that or you can just say n equal to minus equal to 1, right? Because now the heap is reduced by one element. Now, with that in mind, what we have to do? We have to check for the root. Is it, uh, greater than uh, the two children that it has, correct? So what we'll do here, we'll start from, let's say I is 0. Okay. So what I need to check, I need to check its left and the right index. Again, same idea. Left index is going to be 2 into I plus 1. Right index is going to be 2 into I plus 2. Okay. Or left index plus 1. Let's make it simpler. Okay. And what I need to check, I need to check whether heap of I is greater than both heap of left index, right, and heap of I is greater than heap of right index. Is that okay? This condition has to be true at every moment. Right? Now the point is wherever, so in case it becomes false, right, I need to swap it, correct? So if, let's say, not of this, correct? If it is not true, then I need to find which is the largest, larger among the two children, right? So for that, I will just say, yeah, so if heap of, let's say, left index is greater than heap of right index, So max child index, or let's say the child that you need to swap with is basically the left index. Correct? Else, child index is basically the right index. Is that fine? So now what I need to do, if it is not the case, I just need to swap the whatever child index I've gotten here. It could be the right or the left, doesn't matter. I just need to swap the child index with the parent. What's the parent? I is the parent currently, right? So let's just make that also a bit clear. We'll call this parent index. Okay. So I'm checking. I'll start with the root, right? And then the left index and the right index of the particular parent, whatever parent it is, right? And check whether this condition is true or not. If it is not true, I need to find the maximum one and then swap it. So heap of, so we'll take the same idea, same code from here, and then swap it. Is that okay? So parent and child, let's swap with child and parent. Okay. Now, again, remember this particular operation might have could have led to a inconsistent heap going forward. So I need to now make the update the parent, right? I need to check in that particular new subtree what is happening. Correct? That is the idea. I mean, that's the point that we're trying to check. So with this, so we now have to make the parent to be the child index. Remember, whenever the parent, so in this next iteration, which you will do, right? The idea is that you want to now consider the whatever child was changed, right, as the new parent. Need to check that particular nodes left and right values. Okay, fine. So for that, what we'll do, we'll check while parent index is less than n. Um, yeah, okay. Yeah, so parent index becomes the child index, right? Now, right? So what we want to check is we want to check until the parent index is less than n, right? Once it crosses the crosses n, we also don't need it anymore because the heap is ended. So we'll do that in this loop. Okay, so keep on doing this sort of an idea until we get this sort of this condition is true. Again, remember here once you find this condition is true, right? You can actually break this loop. So if I can do this here like this, and just break it. If not, you will go over doing this. And again, remember, left index, right index are for the parent that you have. So you need to update them once you're inside the loop because the parent has changed now. So you need to update the parent index. Is this okay? Any thoughts, any doubts? What remains here, by the way? Anything that's pending to be done? Again, remember, we need to just return the max value. So let's do that here. Is this code correct? Anything we need to check before we move forward? So see, in previous, when we were inserting, we for every child there is obviously a parent, right? But here for a parent, you might or might not have the left child and the right child and so on, right? So those conditions you have to check. Is that okay? Correct. So if left index is less than n, only then you will hopefully compare with the left child. Okay. let's say this condition, you can have it here. And right index, let's say, is less than n. So then, so in this is the case where you have both children, correct? And so therefore you need to check for both of them. Is that okay? If both children are present, then you check with both. The parent has to be greater than left child and the right child. And if it is so, we're done. Not we don't have to check anymore. Correct? But in case it's not true, then what we need to do? We can do one of them, right? So basically, if left index is less than n, okay. So then, so if this condition was false and we have come here, and we have come here, that means right index, there was no right child. There is obviously going to be a left child, right? So then you can just check if it's greater than left child or not. Is everyone getting any doubts in this matter? Okay. So so by the way, if I if like so right index existence guarantees you that the left index is there, right? Because again, remember, we're doing basically this sort of like a sequential storing of the array, right? So in case your right child is there, that means left child will obviously be there. So this condition becoming false, there are two possibilities. Either the left child, right child, both are not there, or the right child is not there, right? So we check first, both are present or not. If both are present, we need to check this. In case only one is present, the one that is present would only be the left child. So we're checking whether the left index is less than n. Okay. And this condition basically comes up here. Else. Correct. So in case your in case the parent has both left and right children, right, and it's failing with compared to either of them, then we want to know the child index with which we want to swap. Correct. In this case, the child index will just be the left index. Right? There's only one child, and it's not greater than that particular child. So therefore, we have to we'll consider it to be the child that we have to swap with. Okay, and then you just continue this idea. Is this okay? So guys, I will not understand whether you have understood or not without you responding. In case there's a doubt, please let me know. And here the else condition is just going to be basically saying that there is neither there are no left children and right children also. There's no left child and a right child. So you already reached the end of the particular, it's a leaf node. So you can just basically break the loop immediately here. Okay. So we are breaking the loop for in three possibilities. One, if left child and right child both are existing and the parent is greater than both of them, then we are done. Not to worry. In case there's only left child, there's only one child, left child. If it is if the parent is more than that left child, then we'll stop the loop. No worries anymore. And in case there are no children at all, right, then we again stop the loop. Okay. And in case there is in case the loop is not stopped until here, that would basically mean that there is some swapping that needs to happen. So that swapping again depends upon so with which child the swapping has to happen. Does it so it happens with the respective child in this case whichever is the larger one. In this case, because it's only one child, we'll just take that particular child index as a left index. So let's see whether we get the proper output or not. So we had this initial heap, we are inserting it, and then this initial this one, and then we'll see if we get the right output. Okay. So the 21 we get. It's not a bubbling up. Okay. This is a more cleaner solution in delete max. Get that here. Let's see. Yeah. Right. So we get 20, 10, 12, 3, 4, and 6. This is the heap that we need. Okay. Okay. So I've provided the exact solutions here. Again, heapify and heap sort. So again, remember, so what is heapify? Anyone remembers what heapify is? So heapify basically, let's say you have a collection of numbers, right? So one way to build the heap from this collection of numbers would be basically adding one element one by one into the heap, right? The other way could be basically yeah, could be to basically just consider the second half of the elements to be the leaf elements, right? So already when you have so so the leaf elements are already in a heap conditions satisfying scenario, right? What we just need to then compare is the top half of the elements, right? So each of the roots of the subtrees, we just have to check that whether it is greater than its leaf elements and so on. If it is so, we just if it is not so, we change the we do the swapping in this particular format, right? Where we find the right child index to swap with, and then the parent and the child basically get swapped. Okay, is that so? That's the idea of heapify. And once you so that basically builds the heap in a order of n time scale compared to order of n log n. Which would be the case if you were to do going to do one by one. And heap sort, the idea is that once you have a heap with you, then you can just keep on removing the max element one by one, right? And keep on changing the heap at every iteration, right? So that will basically give you a sorted array in a descending order, correct? And if you want ascending order, you will basically use a min heap right here. Okay, is that clear? So and then remember, if you want to check whether a heap is min heap or not, all the conditions where you were checking whether something is greater than the parent is more than the children, it will be the opposite. Parent has to be less than the children, less than or equal to children. Okay, fine. Um, uh, so backtracking, one example that was present in the lectures is about the Queen's problem. So one other example could basically be this sort of subset sum, right? So basically, let's say you have a list of positive numbers with you, and you want to find all those subsets in this particular set of numbers which match, which when added give you the target value. Target here is basically 7 in this case, right? So the idea here is that, let's say, if you were to consider 2, it's possible that the sum some values going forward will make the sum to be 7, right? So at every moment, you're sort of branching out into multiple possibilities, whether you consider a particular number or you don't consider it, right? And let's say you get a clear cut signal going forward somewhere that the sum is obviously more than 7, then you will not consider that particular set, and you will not continue anything on the particular path forward. For example, here, let's say if I were to consider, let's say 2, 1, and 6, right? So I would get a sum which is greater than 7, which is 9, right? So then it doesn't make sense to continue with 7, trying to take 7 in that particular set or not, right? So hence we don't explore all possible subsets, but only those which are uh, you know uh, 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 which have a possibility of reaching the particular target or not, right? That's the only that's the catch. So hence we do it in a backtracking sort of a scenario system, right? So where you consider a particular solution if there is a possibility for it to be to become a full solution going forward. Okay. Uh, so one question. So in case uh, I allowed numbers which are negative also, uh, will backtracking help us in any way? Any thoughts? So see, the idea here is because of the fact that it's positive numbers only, uh, there's a clear way to decide when to stop a particular branch, right? In this case, it would be whenever the subset sum is already more than the target, right? But if you allow negative numbers also, then even if the number if the current subset sum is larger than the target, it's possible that you might find a negative number going forward, which will bring back the sum to the target. So hence, in such scenario, you have no other option than to just go through all possible subsets, right? In this scenario, where you allow the numbers to be only positive, you can try to not explore all possible subsets and do it and try to find the subsets in a bit more intelligent manner. Okay, that's the idea of backtracking. Okay. Um, and the systematic exploration which the professor taught, there was no code present, so I have just put down the code here, so you can try it out and see whether it helps you understand the concept a bit more. Same thing with the permutation also, where you were trying to look at, let's say, what would be the next possible permutation from a given string sequence. Okay, so that will I mean, these codes can help you see how to make it better and stuff like that. uh, So I'll stop the session here unless we have any specific doubts or questions. Any doubts from this session? Okay. So we'll meet in the next next Tuesday, same link.